Dengar.
Dengar saya. Okay, we continue our section, this section. So previously we have learned about the basic gates. So now we will learn about the Boolean theorem. What is it? What is this Boolean? What is the theorem on this Boolean? So basically, so the terms is normally used in equation. Okay. So Boolean theorem or Boolean algebra is a mathematical digital system. It's used for digital circuit analysis. So we have variable, complement, and literal. So what is variable is a letter or any variable that can have 1 or 0. So we have used it in the equation A, B, C, until Z, small a, big A, for example. And you have also seen the complement, how we write the complement, the inverse of variable. And literal is basically both variable and complement. So basically the easiest terms is an equation. So first we look on the Boolean algebra, or what we call the Boolean addition. So the Boolean addition is called the sum term or sum literal, sum of literal. In logic circuit, the sum term is produced by an OR operation, which is no involvement of AND operation. So the easiest way to write is maybe, okay, the Boolean addition is just A plus B bar, A plus B plus C bar. So this example of the Boolean addition. A sum term equal to 1 when one or more of the literals are 1. Okay. So if the literal, for example, is 1, so the output is 1. Input is 1 here, so the output is 1. So 1, so the output is 1. A sum term equal to 0, only each of the literal is 0. So each of the literals means each of the input is 0. So here, so the output is 0. So this is just a way, this is just a sentences again to represent the what called the Boolean addition. So beside Boolean addition, we have the Boolean multiplication, and this time is used the word product term or product of literals. So the product terms only involve with the AND operation and not involved with the OR operation. So for example here, the Boolean equation is AB bar or ABC bar. Okay, so here for the Boolean multiplication is use the term product term. So previously we are using the sum term, sum representing the Boolean addition, and here the product term representing the Boolean multiplication. So the product term equal to 1, only each of the literals are 1. So each of the literal input is 1, only the output here will be 1. Another product terms equal the second sentences, product terms equal to 0 when one or more of the literal is 0. So if the input is 0, so the output will be 0. So this is just explaining about the Boolean. Okay, so there are three categories of law or Boolean algebra. So we have the cumulative, associative, distributive. So let's see. It's better to see what is this based on the example. So the cumulative laws, for example here, so A plus B equivalent to B plus A. You just change the position of A and B. So it's representing the same Boolean algebra. A plus B is equivalent to B plus A. And it's the same for cumulative law. For multiplication, okay, A times B A times B equivalent to B times A. So yes, the first law is the cumulative law. Either for the addition or for multiplication is it's just you changing the position. The second one is the associative law. So basically this law is, you have learned maybe in the mathematics, okay, on algebra. So the associative law, for example, A plus B plus C, actually you can do to solve the A plus B first and plus C. So this is the uh, how the associative law. So actually basically you can solve A, B first, then add with C, or you can solve B plus C first, then you add A, or you can solve A plus C first, then you add with B. So this is how the associative law is work. And it is same for the multiplication. You can solve BC first, then you multiply by A is equivalent to you solve the AB first, then multiply by C. So this is what called the associative law. As I mentioned before, you have learned maybe in your mathematics form 4, form 5 on the algebra. And finally, the distributive law is is the expanding expression. You can expand A, you solve B plus C times A, so actually you can expand is equivalent to AB plus AC. Although you change in the equation, but okay, you need to see that the circuit used here is different. It can produce the same output, but the circuit used here is different. Here you are using only 2 gates, but here you use 3 gates. Here, okay, 2 gates, 3 gates. But this distributive law doesn't care about how many gates you are using, but it's just to show that you can expand the equation. Okay. So in order, for example, okay, some circuits you may need to reduce the number of gates used. So you need to modify whether to expand then reduce the equation in order to reduce the number of gates used for your circuit design. So in order to manipulate the Boolean algebra so that you can reduce the number of gates being used in your circuit design, so you need to refer these basic rules. So for the Boolean algebra, you have these basic 12 rules. The rules number 1 to 9 is the easy one because it's just based on the basic gates or the basic logic gates. But the 10 to 12 is you need to do some derivation. Okay, for example, number 1, A plus 0 is equivalent to A. So it's just a rule of addition or gates. So A plus 0 is A. Why is that? If A is equivalent to 0, then the output is 0. If A equivalent to 1, so the output is 1. So that's why A plus 0 is A. Alright, I repeat again. Number 1, A plus 0 is equivalent to A. If A is equivalent to 0, then 0 plus 0 is 0. If A equivalent to 1, so 1 plus 0 is 1. So that's why A plus 0 is A. So rules number 2, A plus 1 is 1. So no matter whether A is 0 or A is 1, so the output will always 1. Rule number 3, A times 0 is 0. Okay. A times 1 is A. A plus A is A. A plus A bar is 1. Okay, number 6, A plus A bar is 1. So that means 0 plus 1 is 1. Okay. A times A is A, number 7. A times A bar is 0. That means 1 times 0 is 0. Or 0 times 1 is 0. A double bar. A double bar is A. Okay. So that means A being inverse and inverse again. Okay, number 10, 11, and 12, we see this example. So how A plus AB is equivalent to A? So you need to use the law of distributive law. So you can have A 1 plus B. Okay. You do the distributive law, A1 plus B. So you know now 1 plus B is equivalent to 1. So A times 1, and the answer is A. So you can see that here you need to use maybe how many gates? You need to use 1 gate, AND gate, another one is OR gate. You need to use 2 gates. And by using this equation, you only get, you don't, maybe not need any gates. Okay, so you are reducing the number of gates. Rule number 11, A plus A bar equivalent to A plus B. How we want to get this A plus B? So A plus A bar, okay, so actually you can expand or use the rule number 6. So A plus A plus A bar B, so is equivalent to AB plus A bar B. Because of what? Because rule number 10 here, okay, so actually A, you can expand itu A plus B plus A plus A B. And here, okay, then after that you can factor the A and factor the B. So A plus A bar. And then you A plus A bar is equivalent to 1. So you get the A plus B. Here, for example, from this equation, you need to have 1 NOT gate, 1 AND gate and one OR gate. But here in this equation, you only need one OR gate. So that's why it's really important for you to understand or to know how to use these 12 basic rules. So next, the final one, okay, A plus B times A plus C is equivalent to A plus BC. So this one you need to expand, okay, so you get this, okay, you got this, and then use all the, based on the rules, A times A, so you can get A plus AC plus AB plus BC. So then you factor, so you factor this A, so 1 plus C is equivalent to 1, and so you have A plus AB, then you factor again, A1 plus B here, plus BC, and finally you get the A plus BC. So you can imagine that how many gates you are using here and here. So here you have the what? You have 2 OR gates and plus 1 AND gate. And here you have 1 OR gate plus 1 AND gate. So by doing this, you are reducing the equation and you are reducing the number of gates used for your circuit. So maybe you can try this after this to do your own derivation based on the notes. Okay, besides these 12 rules, we have also the theorem De Morgan. Okay, De Morgan theorem. So De Morgan theorem is basically, yeah, actually it's based on the XOR or XNOR. Okay, so the first theorem, XOR. Okay, the first theorem, X plus Y bar is equivalent to X bar times Y bar. So this is the theorem. Okay. So you can prove it using the truth table whether it is correct or not. So it seems here, if xy is 0, 0, then the output is 1. The others, for the other case, the output is 0. So this not, sorry, just now I mentioned about the XOR or XNOR. So this is not related to that. This is just, you want to further simplify the equation. Okay. So X plus Y bar is representing X bar times Y bar. So this is the first theorem of De Morgan. The second theorem is X times Y bar equivalent to X bar plus Y bar. Okay. So this, again, I mentioned that it may be used to read, to shorten the equation and further reduce the number of gates being used in your circuit design. So here, De Morgan theorem, you have two. So X, the first one is X plus Y bar equivalent to X bar times Y bar. And another one is here. So you need to memorize this simplification using the De Morgan theorem. Lagi 1240. Okay, so this is what I mentioned Y. Okay, so this based on the equation, because the Boolean equation, from the Boolean equation, you need to draw the circle. Here, for example, AB plus A, B plus C plus B times B plus C. So you need to transfer it into the gates. Okay. So how many gates you can see? If you draw based on this, so the first equation A times B. So you need to have a draw. Boleh tulis. Oh, okay, nampak A, B. So this is A times B. Okay, and the output is AB. And next, you need to add first B, C. So you add first B plus C. So here you have the A times B plus C. And then the last one is B plus C. So B plus C. Okay. So how I write here? So maybe you can do it in order step to derive it, or to draw the diagram, the circuit diagram. Okay. So here you can see that you have how many gates here? Five gates. And actually it's better for you to simplify it. So you simplify the Boolean equation. Here, B plus A, C is just an AND gate. Okay, addition with the OR gate. So here you get advantage of faster design, compact design, and or low cost. So another example here, before we end our class. Okay, find the Boolean expression for given logic circuit, then simplify the Boolean expression. Okay, so this time, okay, it's only give the Boolean, it's only give the circuit diagram. So you need to derive the Boolean expression, and then from that Boolean expression, you need to simplify the Boolean expression, and then maybe you need to redraw the new logic circuit. Assume that this answer is not yet given, so you try to get the Boolean expression from the circuit. So you can derive one by one. So saya nak derive ni. Okay. So here it goes, X goes to not gate. So you have the X bar. So here you have the Y. So that's this is how we derive the equation, and then we have the Z. So here you will have X bar, Y, Z. So here you have the what? Okay, you have the X bar again. Here we have the Y, and here we have the Z bar. So you will have the X bar, Y, and Z bar. Here we use the 3 input AND gates here. Okay, next what we have here? We have the Z, and we have the X. So from here we have the XZ, and then we do the addition using the OR. So here we can derive that F is equivalent to X bar YZ plus X bar YZ plus xz. Okay, so you get the Boolean expression. Now the next step is to what? To simplify the Boolean equation. So next step is to simplify. So macam mana nak simplify? Apa benda yang boleh difaktorkan?
X bar Y.
Okay, you want to factor y first. I don't know, maybe we x bar y.
X bar Y.
So then we have the z plus z bar. Plus xz. Okay, so z plus z bar is what? Z plus z bar is 1. So you have the x bar y plus xz. This is the last. Okay. So is this the you can, is it you can further simplify? Selesai.
Cannot.
Tak ada. Ada tak equation daripada yang 12 rules? Ni, sekejap, sorry. Okay. So dah ada pun next slide rupanya. Okay. So this is number 2. You do the simplification, and then from that simplified Boolean expression, you draw the logic circuit. So here, okay, you have the NOT gate, you have the AND gate, and you have the OR gate. So based on the simplified equation. Okay. So from this section on Boolean, so you have learned about, as a conclusion, you have learned about the how you want to generate the Boolean equations. You have learned about the laws and also the rules, 12 rules in order to simplify the equation. Why you need to simplify the equation? Actually, you need to reduce the number of gates. So because if you are using a longer equation, you may need a number of gates. And when you simplify the Boolean equation, so you can reduce the number of gates. Why we need to reduce the number of gates? Number one, because you want to reduce the cost. Yeah, a lot of number of gates, you may have an expensive design. Second, you may reduce the delay caused by the lot number of gates being used. Third is maybe you want to your design to make it a compact. Compact mean maybe before this you need a lot of gates. By reducing the number of gates, you can put it maybe in your handphone with a more compact design. Okay. So as an exercise for tomorrow, because there is no class, you can try to do this exercise. Okay. So it's given for you to try. I advise you to try. It looks simple, but if you cannot solve it, you have a problem. Okay, it's all based on the 12 rules. So you can do this exercise. The tougher one maybe to use the Morgan theorem, but I think if you try, you can solve the expression. Actually, it's just for you to simplify the Boolean equation, and from that Boolean equation, you can reduce the number of gates being used. Okay, so this exercise is from Boolean equation. You can simplify the logic circuits and also this. And the last one is from the logic circuits. Okay, this one is from the logic circuits. You get the Boolean expression, logic circuits. You get the Boolean equation from this, and from that Boolean equation, you get the simplified Boolean equation, and from here, from that simplified Boolean equation, you draw again the new logic circuit, and you compare whether you able to reduce the number of gates. So here, this question F1 and F2. So please do this at home, and maybe in our next class, before we start with a new chapter, we can discuss this during class hour. Okay, so with that, any question before I end my class? Ada komen ke tentang saya ke? So I try to explain slowly, but at the end, okay, you yourself, you need to try to do the exercise for you to understand. So kalau tengok saja dalam kelas saja tak, you without practical doing, you may have problem. Okay, you look, you seems look how I teach is easy, but without doing exercise, it's still difficult for you to solve the problem. So my advice, so since tomorrow no class, so you can use the hours for you to do the exercise. And if you have problem, maybe we can discuss on the class time. All right. Okay. Ada question? Any more question?
No question, sir.
Okay. If no, sudah lapar. So, okay. With that, I end my class and see you next week on Wednesday. Puasa lah. I'm not sure. Next week, we will see whether it's the first Ramadan or not. If first Ramadan, it's holiday. If
No,
not,
sir, second.
oh, second. Okay, so then we proceed with the class. All right, thank you, and happy fasting. Selamat menyambut puasa lah in 6 days time for Muslim. Okay, Assalamualaikum warahmatullahi wabarakatuh, and thank you. Bye-bye.
Thank you, sir.
Waalaikumsalam.
Thank you, sir.